This is Algebra 2, Lesson 1.4, and in this lesson we're going to summarize the three different sequences we've been looking at and then talk about what their graphs would look like. So I have this table already filled out and I'll just kind of talk about it. You can pause as you need to. But the first sequence we talked about was the arithmetic sequence, and the arithmetic sequence was the sequence that uses addition or subtraction. So the general form looks like that. We have to get the next, you take the last, and we add the common difference. And if we need to know the common difference, we would take the second number and subtract the first number. An increasing arithmetic sequence should be a straight line going up. A decreasing geometric sequence should be a straight line going down. So straight or linear would be another descriptive word to illustrate that. Whenever the difference is bigger than 0, it would increase. Whenever your difference is less than 0, it would decrease. The second type of sequence we talked about was the geometric sequence. And the geometric sequence is the sequence that we get through multiplication. So my general form here would be that I multiply by my ratio. And to get my ratio, I take my second number and I divide by my first number. There's also the option to get my ratio through a percent increase or a percent decrease situation. So 1 plus the percentage on an increase or 1 minus the percentage on a decrease. So none of this should be new. We talked about this on lesson 1.2. We're just summarizing it in one place. And a geometric increasing sequence would happen when the ratio is bigger than 1. A geometric decreasing situation would happen when the ratio is less than 1. Those should always be curved, and our word for that is nonlinear. The third sequence we talked about is the shifted geometric sequence, and that happens when we use addition and multiplication in our formula. So here's my general form for that. To get my next, to take my last, I would multiply it by a ratio and I would add a common difference. So there's no real formula to determine these values, but we do have a formula to determine the long run value. So the long run value would be the difference divided by 1 minus the ratio. And so usually, almost all shifted geometric sequences have a long run value. Sometimes they don't. But if it's an increasing shifted geometric sequence, it would increase to that long run value and level off. A decreasing one would decrease from the starting value and then again level off. So this happens when the starting value is less than the long run value, and this situation would happen when the starting value is greater than the long run value. And just like the geometric, because the shifted is geometric, just like it would be nonlinear or curved each time. On the next 2 pages of your packet, you'll notice something called an investigation. That is extra credit. You do not have to do it, but you can choose to do it and earn additional points. So this page here is extra credit, and this page here is extra credit. The exercises would follow there. The exercises are the assigned for points portion that you need to do for your grade. Okay, so that's it for the notes. Good luck with the exercises, and please let me know if you have any questions.